Hi, welcome to the Olympiad geometry. Let's continue our study on the intersection circles. Before that, if you feel this video is helpful, please click the like button. Welcome to share it to anyone may interested to this topic, and please subscribe this channel. Here is a problem. Radius of circle O1 and circle O2 are R. Two circles intersecting on MB. AC are 2 points on circle O1 and circle O2 respectively. ABCD is a parallelogram. Prove triangle AMD circumcircle has the same radius R. Okay, circumcircle of triangle AMD has the same radius R. So as previous video, we actually proved one problem that we want to show a triangle. Two triangles has the same circumcircle radius, right? So based on that experience, let's just think about this problem. We want to prove that triangle AMD, the circumcircle of triangle AMD, has the same radius R, which means that we can imagine we have a circle here that intersects the circle O1 on MA, right? And we want to prove that this circle has the same radius. So we can directly say, oh, if we can find that the common chord AM reference to the same circle, same angle, like ADM equal to another angle inside of the circle O1, then we just prove it, right? So for this problem, there is a very powerful method called construct. We will talk more about this method in future, but let's just use it for now. We see here we find a parallelogram that ABCD, right? So we can directly just build another parallelogram. Let's call it ANMD. We just build a parallelogram ANMD, right? So we know that AN is in parallel with MD, and AN equals to MD, right? Also, NM is in parallel with AD, and NM equals to AD. So we can connect NB and MC. Right, because AD is in parallel with NM and AD equals to NM, and AD is in parallel with BC, AD equals to BC. That means NMCB is a parallelogram. Right, so we have NM is in parallel with AD in parallel with BC. NM equals to AD equals to BC. Right, based on this, we know that NMCB is a parallelogram. Okay, NMCB is a parallelogram. That just tells us that angle MNB equals to angle MCB. Right, angle MNB equals to angle MCB. we know that if angle, because O1 and O2 has the same radius, that means the common chord, any angle reference to the common chord are equal, right? And we know that MCB equals to MNB. That means point N is on circle O1. So and we know that point N is on the circle O1. Let's just put it here. Right. Point N is on the circle O1. And we already know that angle ANM equals to angle ADM. Why? Because NADM is a parallelogram, which means that AM is a common chord for the circle O1 and the circumcircle of triangle AMD, right? And angle ANM is reference to common chord AM. That means, and we already know this condition, that means this circle equals to this circle. So for the same chord, the angles reference to the same chord are equal, which means the radius of the circumcircle of triangle AMD equals to the radius of O1. Right, so we just prove the problem. You may ask, how could you at the first time figure out to do a parallelogram? Because once we make this construct, everything is very easily solved, right? This actually comes from the experience and the multiple times of the construction problem exercising. So we will talk about it later. But for this problem, there is a particular sign that you should use the constructor, because we want to find the angle inside the O1, inside the circle O1, right, with the chord AM, so that we can prove that this angle, the angle ADM, equals to that angle. And the easiest thing to think about that we want to find another angle that uses the same chord is to draw a parallelogram. And we already have a parallelogram here. So to construct a parallelogram would be I would say it would be a very easy thing to think about once you are familiar with the method and have multiple times of the experience of using it. Okay, that's today's video. Hope you liked this video. Thank you.